Hi guys, this is lesson 93 for algebra. It is called dividing polynomials. This lesson is going to get ugly and it's going to take a little bit of time, especially when I show you long division, so make sure you have paper around to do some work. All right, we are going to be dividing polynomials. So remember, a polynomial is something like a binomial that has 2 terms or a trinomial that has 3 terms. So let's start with one that we can factor. So let's say we had 6x to the 4th plus 4x to the 3rd minus 2x squared, and we want to divide that by 2x. Well, I'm going to start with looking at my numerator. Can I factor it? Yes, I can. Everything has a 2 that can go into it, and they all have an x squared in common. So if I take out the 2x squared, 6x to the 4th divided by 2x squared is 3x squared. I'm going to add 4x to the 3rd divided by 2x squared is 2x. And I'm going to subtract 2x squared divided by 2x squared is 1. And I can't factor my denominator, so it stays the same. All right, now I'm going to look for things that I can cancel. I can cancel my 2, and I can cancel one of the x's, which means I'm left with a plain old x here. So right now I'm at x times 3x squared plus 2x minus 1. And to get my final answer in its simplest form, I'm going to distribute that x to all 3 terms, and I'm left with 3x cubed plus 2x squared minus x as my final answer. All right, let's look at another one. Just like that, I have x squared plus 5x minus 14, and I'm going to divide by x plus 7. Anytime you see an x squared and a single number at the end, you should try to factor. So if I want to factor my numerator, I know that x times x will get me x squared, and I know that a combination of 7 and 2 will get me to 5. I want positive 5, so I'm going to do plus 7 minus 2, and I'm going to divide that by x plus 7. This should look familiar. We've done these before. If you cancel the x plus 7s, you are left with x minus 2 as your final answer. All right, for question number 3, it is going to be fairly similar to question number 2, but I'm going to change the denominator to 2 minus x. All right, so I already know how to factor my numerator because I just did that in the question above. But what I want to do is rewrite my denominator so the x comes first. So, sorry, I just realized you can't really see that. All right, so I really have negative x plus 2. Now you'll notice that I can't cancel anything yet, so what I really need to do is rewrite this. So if I divide both of these by negative 1, then I'm left with negative 1 times x minus 2, and you'll note that my parentheses now match. So if I rewrite this just to make things a little bit clearer, I have negative 1 over x minus 2. My x minus 2's can cancel, and so I'm left with x plus 7 over negative 1, which is really like a negative x plus 7, and that would be my final answer for that specific question. All right, now we're going to get into really ugly long division. So bear with me here. It's not pretty and it takes a lot of work. The reason we have to do this is because we can't always factor every numerator that we get. So if you remember, when I have a 3-digit number divided by a 2-digit number, I say, all right, how many times does 21 go into 56? My answer would be 2. I'm going to subtract 2 times 21, which is 42. 6 minus 2 is 4. 5 minus 4 is 1. This number is smaller than this number, so I know I didn't need to add another time that it goes in, right? And now I know that 21 times 7 is 147, and so I'm left with 0, which means I have no remainder. So what if we had a trinomial like x squared plus 3x plus 2, and I wanted to divide by a binomial? Now this one I know I can factor, but I'm going to show you what long division is like with an easier one first. So I'm going to say, okay, what do I have to multiply x by to get x squared? and I know that x times x is x squared, but I have to be very careful that I line things up. So because I'm multiplying by x, I'm not going to put it above the x squared because the place value would be off there. So I'm going to put it here because x times x would get me x squared. All right, so now I'm going to multiply, just like I did here where I did 21 times 2. I'm going to do x times x plus 1. So x times x is x squared, and 1 times x is x, right? But remember, when I do long division, I subtract whatever that answer is. So x squared minus x is nothing, and 3x minus x is 2x. All right, just like in long division where I bring down my number at the end, I'm going to bring down this plus 2. So now I'm going to say to myself, all right, what do I multiply x by to get to 2x? And my answer is a plus 2. So now I'm going to multiply 2 times x is 2x, and 2 times 1 is 2, and I am subtracting that, and so I get 0. So my answer here would be x plus 2. Okay, that was a really long way of going about that because I could have just factored this originally, but let me show you some really ugly ones where I would not want to factor. All right, so this one is 13x squared plus 5x minus 42. And I'm going to divide that whole thing by x plus 2. Now, I don't want to even try to factor 13x squared and a 42 at the end. That'd be a lot of different options I have to try to get to 5, and that just doesn't sound like fun to me. So instead, I'm going to do long division. So I'm going to say, all right, what do I have to multiply x by to get to 13x squared? And my answer would be 13x. Now I'm going to multiply. 13x times x is 13x squared, and 13x times 2 is 26x. And remember, I am subtracting this. So 13x squared minus 13x squared gets me to 0. And 5 minus 26x gets me a negative 21x. And then I bring down this negative 42. All right, so now I'm going to say, all right, what do I have to multiply x by to get to negative 21x? And that would be a negative 21. So I'm going to multiply negative 21 by x and get negative 21x. And negative 21 times 2 is negative 42. And this is where it gets funky because remember, when you are doing long division, you're actually subtracting whatever that number was. And so when I subtract a negative, it's really like adding the opposite. And I also have to add the opposite down here. And so negative 21x plus 21x is 0, and negative 42 plus 42 is 0. So my final answer up here would be 13x minus 21. All right, that was a lot of work to get there, and it was kind of weird. Let's try another one and see how it goes. So let's say we have 4x squared plus 7x plus 17, and I want to divide that whole thing by x minus 3. You might want to pause the video right now, take a minute and see if you got your work right, and then restart the video and check your answer. All right, so I'm going to say, okay, what do I multiply x by to get to 4x squared? And that would be a 4x. Make sure you lined it up in the right spot. 4x times x is 4x squared. 4x times negative 3 is a negative 12x. All right, I am subtracting that. So 4x squared minus 4x squared is 0. And this is where it gets funky. Watch your negative signs. 7x minus a negative 12x is really like adding the opposite, right? So 7x plus 12x would be 19x. All right, what do I have to multiply x by to get to 19x? Well, that would be 19. All right, 19 times x. Oh, sorry, I forgot to bring this down. Okay, 19 times x is 19x, and 19 times negative 3 is, oh, let's see, what's 19 times 3? 27, 57? All right, 57. So remember, I am subtracting these. So 19x minus 19x is 0, but 17 minus negative 57 is like adding the opposite. So 17 plus 57, 7 plus 7 is 14, 5 plus 1 plus 1 is 7. So what happens when I have a remainder down here? Well, anytime we have a remainder, remember we take this number and we put it as a fraction over what we were dividing by. So my final answer for this is going to look really ugly because I need a remainder of 74 over x minus 3. And I really should add a plus sign in between there. So let me rewrite that for you at the bottom so it makes more sense. So when I did the division, I had 4x plus 19. And then I have this remainder that I'm adding on of whatever was left over whatever I divided by. So this is a super duper ugly answer, but that is actually your final answer for that question. All right, let's try one more with an ugly remainder. So if we have 6x squared minus 7 plus 3x cubed, and I'm dividing by 4 plus x, the first thing that you should see is that this is out of order. It's not in standard form. So I'm going to rewrite it in standard form. 3x cubed plus 6x squared minus 7, and I'm dividing by x plus 4 because I'm going to put that in standard form as well. All right, what do I have to multiply x by to get to 3x cubed? Well, that would be a 3x squared. Make sure you line it up. 3x squared times x is 3x cubed. 3x squared times 4 is 12x squared. Remember, I'm subtracting this. 3x cubed minus 3x cubed is 0. 6x squared minus 12x squared is negative 6x squared. And so now, how many times, or what do I have to multiply x by to get to negative 6x squared? Well, that would be a negative 6x, right? And this is where I forgot to add a placeholder. So I can't put negative 6x there because it doesn't line up with the 7. So what I have to do instead is add a plus 0x and then put my minus 7 in there again. Do you see how I added 0x, and that would add, that adds no value to my original expression because 0 times anything is 0, but it helps me line things up. So I'm going to bring down my 0x, and now I have negative 6 times x is negative 6x squared, and negative 6x times 4 is negative 24x. I am subtracting these, which really means I'm adding the opposite on everything. Negative 6x squared plus 6x squared is 0. 0x plus 24x is 24x. And then I bring down my negative 7. So what do I have to multiply x by to get to 24x? Well, that would be a 24. So 24 times x is 24x. And 24 times 4 is 16, 96, so plus 96. I am subtracting these, so 24x minus 24x is 0, and negative 7 minus 96 is really like 96 plus 7, which is 103, and it's negative, right, because they were both negative. So now here's my ugly remainder, and so I am really subtracting because it's negative. 103 over x plus 4. And so this super long, ugly thing is my final answer. All right, your Alex homework has quite a bit more practice of these. You can also look at page 620 of the textbook. That will give you some more examples as well. And if you need help, shoot me an email or feel free to ask. All right, talk to you later. Have fun.